Hello, this is Mr. Kuzinski, and today I've got your first lesson of Math 8. It's going to deal with number lines, comparing and ordering integers. Now, you should have your note sheet out and everything that I write, and possibly even some of the stuff that I say but don't write, you should write down on your note sheet. And then you'll have that tomorrow when you come in and do our first classwork assignment. I call them problem sets. All right, so let's get started. We're going to talk about number lines and comparing and ordering integers. So let's start out by defining a couple sets of numbers. First of all, the whole numbers are the set of numbers that include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth, and that goes on to infinity. And the way we show that this pattern continues is with these ellipses right here, the dot, dot, dot. Now, if we're going to compare and order integers, then we probably need to know what integers are. Integers include the whole numbers and their opposites. And the way we show those in set notation, and that's what this is, set notation, is an ellipse, -3, -2, -1, 0, 1, 2, 3, and then another ellipse, which shows that this pattern includes starting at 0 and going up by 1 forever, and also starting at 0 and going down by 1 forever. Those are all the integers. Again, make sure you've got that written down in your note sheet. All right, so here's a set of integers. Not the set of integers, but 5 integers, and we're going to order them from least to greatest. A great way to do it is by using a number line. Your number line doesn't have to look exactly like mine, but this one's going to work just fine for us. I'll start at -5 and go up to 5 by ones, and I'll plot these numbers, these integers, -4, +3, +2, -1, and 0. So since -4 is the furthest on to the left on the number line, we know it's the smallest number. Now the next smallest number is -1, and 0, and 2, and 3. So putting these numbers on a number line, plotting them, that's a great way to order numbers. Okay, same set of 5 numbers here. Which of these numbers is an even number but not a whole number? Okay, you got to go back and look at your definition of the whole numbers here. 3, 2, and 0 are whole numbers. So which numbers are not whole numbers? -4 and -1. This is one way to start it. We could have started with the even, but I'm going to start off with which ones are not whole numbers, -4 and -1. And now it says which of the following numbers is even? Well, of these two that are not whole, the only one that's even is -4 because it is divisible by 2. So -4 is even number, but not a whole number. Got 2 more integers here, -2 and -4, and we're being asked to compare them. Okay, well, let's, and compare means which one's bigger, or are they equal? Well, let's put them on a number line real quick. I'm going to start at -5. I'm going to go up by ones. I'm going to stop at 1 this time because I can plot -2 on this number line. And I can plot -4 on this number line. Now, is -2 bigger than -4, or is it less than -4? Well, since -2 is to the right of -4, it is greater than. And here's the symbol for greater than. -2 is greater than -4. Graph the numbers in this sequence on a number line. Seems like we've already done something like this, but it's actually a little bit more complicated than what you might think. Let's start by making our number line. I'm going to start at -5 again. I'm going to go up by ones until I get to +5. Now I'm going to plot these numbers, these integers, -4, -2, 0, 2, and 4. Now I underline these for a reason because these are not all the numbers in the sequence. These ellipses mean that this sequence continues. These ellipses mean that this sequence continues. We have to include those when we plot them on a number line. So the way we show that this continues is by coloring in the arrowhead. And same thing for the positive numbers. Color in the arrowhead. That shows on a number line this sequence is continuing. Simplify these two expressions. Well, the way these symbols right here mean absolute value. So this says the absolute value of -3. Now, absolute value is a number's distance from the origin on a number line. Now, the origin of a number line is 0, always 0. So how far is -3 from 0 on a number line? 1, 2, 3 units. That's it. -3 is 3 units from 0, so its absolute value is 3. So what's the absolute value of 3? Well, 3 is 1, 2, 3 units from 0. So the absolute value of 3 is also 3. Okay, now these two numbers are equal because absolute values are always equal. Distances are always positive. If you drive 3 miles to school, you've driven 3 miles. If you drive 3 miles home from school, you've driven another 3 miles. So it doesn't matter which direction you're heading in, distances are always positive. So use that information. You guys try this one on your own. Write two numbers that are 10 units from 0. All right, the only positive number that's 10 units from 0 is 10. And there is a negative number that's 10 units from 0, and it's -10. That's it. Write an example of a whole number that is not a counting number. Well, the first thing I got to do for you is define the counting numbers. If you had a basket of apples and you were counting them, the first apple you count would be apple number 1. So that's our first counting number. And then apple number 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are all the counting numbers. So the only whole number that is not a counting number is 0. And one way I like to remember that is that whole numbers, a 0 kind of looks like a whole, so 0 is part of the whole numbers, but it's not part of the counting numbers. Some people call the counting numbers the natural numbers also. That should be known. Well, that's our last example for our first note sheet. That took us exactly 8 minutes as of right now. Again, you should have written all of this on your note sheet, and even sometimes if I said something, like I said that counting numbers are natural numbers, maybe you want to write that down, even though I didn't. So bring this in with you tomorrow. I'll check to make sure you completed it, and we'll get started on the problem set or the classwork. So I'll see you then. Have a good night.